So moles is a measure for the amount of substance. And the definition is the amount of substance that contains the same number of particles as Avogadro's constant. Avogadro's constant is 6.023 times 10 to the 23. So that's how many particles there are in 1 mole of any substance. So for example, if you had 1 mole of carbon, there will be this many carbon atoms. If you had 1 mole of chlorine, there will be this many chlorine molecules, because chlorine exists as Cl2. So for example, for 1 mole of chlorine would have 6.023 times 10 to the 23 molecules. If you want to work out the number of atoms, then you need to times that by 2, because each chlorine molecule has 2 atoms in it. So to work out the number of atoms, you do 6.023 times 10 to the 23 times that by 2. And that should give you the number of atoms there are. And that's 1.2 times 10 to the 24 roughly. Okay, so here we have 3 different equations for moles. The first one with moles equals mass over mR. This is when you're dealing with masses. Moles equals volume over 24 dm cubed. This is when you're dealing with gases. So the reason it's 24 dm cubed is because 24 dm cubed is known as the molar volume of gas, which is basically the volume 1 mole of a gas takes up at room temperature and pressure. So any gas, if you have 1 mole of it, will always take up 24 dm cubed. Dm cubed is a unit that comes up quite a lot in chemistry A level. You need to know how to convert from centimeters cubed to dm cubed. And to do that, you need to divide by 1,000. So if you want to go from dm cubed back to centimeters cubed, you times by 1,000. This second equation doesn't come up in AQA. So you don't need to know it if you do AQA. The third equation is for titrations mostly, which we'll talk about later. And the units are very important here. So concentration is measured in moles per dm cubed. Volume is measured in dm cubed, which is important because in normal questions they give it to you in centimeters cubed, so you need to convert them into dm cubed. And moles is measured again in moles. So what are the steps needed in a mole calculation? Let's look at an example first of all. So 23.5 grams of potassium was reacted in oxygen. Calculate the mass of potassium oxide produced. So let's write the equation for this down as well. So it's 4K plus O2 goes to 2K2O. So you got to make sure that your equation is balanced first of all. Okay, so step 1, find the moles of the known substance. So we've got potassium, oxygen, and potassium oxide. So the known substance is whatever we have the information for. So that would be potassium. So we'll label that with a K. The unknown substance will say whatever it is that we're trying to find out. So yes, oxygen is unknown, but the one that we're actually trying to calculate is the mass of potassium oxide. So we'll put a U there to show that that's the unknown. So we're trying to find out the moles of the known substance. We've got the mass, so you got to think about what equation to use. Moles is equal to mass over mR. So you put the numbers in. 23.5 grams, and the mR of potassium, if you look on the periodic table, should be 39.1 grams per mole. Put that in your calculator and you should get 0.601 moles of potassium. Okay, step 2. Use ratios in the balanced equation to find the moles of the unknown substance. So what you need to do here is find the ratio of the known to the unknown. So you look at the numbers in front of each compound or substance. This is a 4, this is a 2. So you want the ratio from the known to the unknown. So that's going to be from potassium to potassium oxide. Potassium has a 4 in front of it. Potassium oxide has a 2 in front of it. So you want basically a ratio of 2 to 1 if you're going to simplify that. So we've worked out that there's 0.601 moles of potassium. Therefore, if it's a 2 to 1 ratio, you need to do 0.601 divided by 2, which gives you 0.3005. And that's the moles of potassium oxide. So we've got the moles of potassium oxide, but remember, the question is asking for the mass of potassium oxide. So step 3, final step, find the unknown using mole formula. So we're trying to work out the mass. So we want the equation for mass. So we're going to use the same equation again. Mass is equal to moles times mR. If we rearrange that equation, moles equals mass over mR. So we do 0.3005, that's the moles of potassium oxide, times the mR of potassium oxide, which is, so K2 is 39.1 plus 39.1 plus O, which is 16. Put that on in your calculator and you should get the final answer, which is 28.3 grams. So let's say that this question has a part B to it. What is the volume of gas required for this reaction? So this time our known is again potassium, but our unknown is oxygen. We want the volume of gas required. So the first step is the same. It's just going to be moles is equal to mass over mR, which gave us 0.601 moles. But our second step, the ratio is different this time. We want the ratio from potassium to oxygen, known to unknown. So our ratio is 4 to 1. So this time, your 0.601 gets divided by 4, which gives you 0.150 moles. And then to work out the unknown, you got to think about what reaction you want. Remember, you want a volume this time. So you're going to use the equation for volume of gases, which is moles is equal to volume over 24 dm cubed. So we can rearrange that to give us volume is equal to mole times 24 dm cubed. So we would do 0.15 times 24, which gives us 3.606 dm cubed. So remember, in this equation, volume is measured in dm cubed. Okay, so there's still one more equation for moles that you need to be aware of, and that is the ideal gas equation, and that is PV is equal to nRT. P is pressure and is measured in pascals. V is volume measured in meters cubed. N is the number of moles, that's measured in moles. R is known as the ideal gas constant, and that's always the same value of 8.31 joules per mole per Kelvin. That'll get given to you in your data sheet. And T is temperature, and that's measured in Kelvin. So one thing that you need to remember is to do the conversions correctly, especially for volume and for temperature. So let's try an example. How many moles of hydrogen molecules are present in a volume of 100 centimeters cubed at a temperature of 20 degrees C and a pressure of 100 kilopascals? So you can tell that they want you to use PV equals nRT because they have given us volume and pressure. So that's one thing to look out for to identify questions where you need to use this equation. They'll usually expect you to do a few conversions in these calculations. So remember, we need pressure to be in pascals. So 100 kilopascals needs to be multiplied by 1,000 to convert into pascals, and that gives you 100,000 pascals. The volume has been given to us in centimeters cubed. We need it in meters cubed. To convert centimeters cubed into meters cubed, think about how you convert centimeters to meters. What you do is you divide by 100, but because this is centimeters cubed and meters cubed, you need to divide by 100 cubed. So that would give us 1 times 10 to the minus 4 meters cubed. And the last conversion will be for temperature. From degrees C to Kelvin, what you need to do is you need to add 273 to convert that. That's just a number you need to memorize. And that will give us 293 Kelvin. Then you just put all of these numbers into this equation. We're trying to work out the moles of hydrogen molecules, so we want N to be the subject. So let's rearrange that. That'll give us PV over RT. So we can do 100,000 times 1 times 10 to the minus 4 divided by 8.31 times 293. And that gives us an answer of 0.00411 moles.
For more videos like this, summary videos, worked examples and exam tips, subscribe to my channel.